Structures, a new chapter. Why there is a need of structure? First of all, that is very important. Since the first chapter, in the first four chapters, you can say, or five chapters, whatever whatever data you want to store, you chose either integer, character, or float or double. I mean, right? Then onwards, we came across one more requirement. What was the requirement? How to access memory remotely, right? Because it was necessary. I gave you some examples as well. If there is some pot, uh, if you want to boil the water, okay, when you put that pot on the gas for boiling, before that you pick that pot along with your fingers, right? Because it is cold. But when you boil that water, you cannot, pick up that pot with your hand. You need some kind of a clamp. Why there is a necessary? Similarly, when you want to access remote memory, okay, or access memory remotely, then you don't have any other option but to use the pointer. So we came across one more additional, but pointer is not a built-in data type, right? Pointer is not a built-in data type. So Dennis Ritchie provided us to create our own data type that we call it as a pointer. Store address of one variable into another variable. So we created a pointer and we could perform many tasks like changing contents of variables in main function from other function, right? You can manipulate the string, you can manipulate the array. Otherwise, it would have been very difficult. Rather, it was impossible. So there was a pointer. Then there came how elements having same data type and same nature can be stored in a single variable. What I said, elements having same data type and same nature. If you want to store, suppose marks as well as integer variable, marks as well as roll number, you never thought of declaring an array. Why? Because data type is same, but nature is different. One is mark, another is roll number. Third is suppose age, right? So you never thought of like that. Instead, you declared three different variables. But if you want to store marks of five subjects, like in the first chapter, you declared five different variables M1, M2, M3, M4, M5. But in the arrays chapter, we came across the facility given by the Dennis Ritchie to declare an array of integers so that you can store marks of five subjects. Right? So single variable marks and indexing is marks of 0, marks of 1, marks of 2, marks of 3, marks of 4. It's like that. So we went one step ahead. So there was an array. String is not different thing. String is after all an array, but it is an array of characters. So we go on building our. We went on building our own data types. Rather, we cannot call them as a own data type, but the uh, derived data type. So pointer is derived from basics, primary constants. That's why it is a secondary data type. So we used to call integer pointer. As far as array is concerned, Array is not a built-in data type, it is a secondary data type. So we used to call array of integers. There is not a keyword like array. There is not a keyword in C like pointer, so that you can declare directly pointer. No, such facility is not there. So they started feeling, can there be a data type which is a user defined data type? And yes, that is possible. See, since pointer is of integer or array is of integer, then and all these are derived. So structure, when we say that structure, we want to design our own data type. After all, we are designing means we are taking help of primary data types, right? Or other derived data types like pointer or a array, right? Using those, we will build our own data type, and that we call it as a structure, right? That we call it as a structure. So uh, there is a syntax how we can, design our structure, own structure, because that's why structure is not just called as secondary data type or a desired data type. Structure is usually called as a user defined data type. The way I want, I will build my own data type. I will explain that. We will see how structure is declared, right? How structure variable can be created, how to access those structure elements, what is array of structure, right? Structure pointer, one more thing. You ask for that array operator, right? And what are the features of structure? So everything we will see this. As soon as this is finished, I will omit some chapters, right? It is not that I'm not going to teach you, but I will rearranging the sequence. As soon as structure is finished, I will teach you malloc and calloc, so that you would be in a position to understand uh, what is going on in your class, right? Now, struct is the keyword, right? How to declare that? Struct is the keyword in C language. Struct is also keyword in C++. In Java, there is not a struct. In Python, there is not a struct. Initially, you will face some friction. Initially, okay, it will take some time to understand need and basically need of a structure, because I will explain that. Right? Suppose there is one student having so if it is a student, he will be having some data, right? So suppose there is a student going to school or college, so he will be having roll number, right? He will be having some name. He will be having age as well. Okay? So there is a age, and they will be having some his address. What else we can add? Uh, um, we can add like int b date, right? Birth date int b, month, int, birth year. Basic data of a student. Now imagine you can take input for all these things. You can take input. But what will you do if you want to store information of another student? Obviously, you'll have to declare one more variable, right? So you have to give your roll number 1 and roll number 2, right? Same here. Name 1, name 2, name 3, age 1, age 2, age 3, address 1, address 2, be date. That is, you have to, how many variables you will declare like this. So on that, probably, suppose I want to store address of, I mean details of 5 students. You will say that I will make an array of this 5, array of this 5, array of this 5, array of address, array of birth date, array of birth month, array of by year. But is it logical? No, it is not logical. There will be an array of roll numbers. There will be array of names because there is no connection between. No, there is no relation. There is no connection. Direct relation between roll number 1 has got this name, this age, this birth date. So these are not logically bind. No. So Dennis Ritchie thought of no binding them together, and he provided the keyword struct. Right. So what I will do, I'll put this inside everything inside a structure. So I will write struct. It is the keyword. I'll give name to the structure. Right. Giving name to the structure is creating our own data type. It is not declaration of variable. So I'll create my own data type. If int is the data type created by C language for storing integer, they have not created data type as integer. They uh, they just thought of creating it int. Even they don't even they didn't think of in as a data type, inte as a data type, intgr like that. Okay, they just thought that int is good. It will reflect what they want to say. So int. As far as character is concerned, they chose char first float characters. As far as real numbers are concerned, they didn't choose real as a keyword. They didn't choose they did choose float as a keyword, right? So this is choosing a data type, the built-in data type, right? So we are creating our own data type. So we are going to decide name of the data type. So we will choose the data type on the basis of what we are going to store. Because when you declare int data type, you can store integer. When you declare float variable, you can store a real constant. When you declare char variable, you can store the character constant. When you declare a pointer variable, you can store an address. Getting what I mean? So if you are declaring a structure, then you can store the information of that structure. So I will give the name. It is up to us what to give the name. Suppose I give name of structure as student. That's it. Struct student. Right? Right? This is actually structure. Right? This is actually a declaration of structure. When you write struct, you are telling the compiler that whatever is going to follow till the semicolon is my structure, rather user's own structure. Right? Now, everything this inside this structure. You want to store this much information, put it inside this. That's it. Right? So now it is no. Once this is no, you have collected in put inside the structure. Now this becomes a kind of a template, right? Kind of a design, you can say. It is a design. Huh? So these are basically structure members. Okay, these are called structure members. All these are structure members. And this is the body of the structure. And semicolon is must. Hmm? Everything is called structure definition. Declaration as well as definition. This is declaration as well as definition. Right? What do you mean? What do I mean? You're telling compiler that student is going to be my own data type and it will be having these many members. Now, since this is a structure, it doesn't take any space in the memory. That might be surprising. But see, this is just a template. This is just the design. Design doesn't take space in memory. What I mean, in your first chapter, perhaps you might have seen that you might uh, have a subject like drawing. Okay, drawing. So on that drawing, suppose you draw something. Okay, some design of something like design of pencil or design of mobile phone or design of compass or anything. You could draw that. Is that taking any space actually in the real world? No, it is not taking any space. It is just design. Design is how the product can be made. So that is the design. This is design basically. We are telling the compiler how I want to create a variable and what data can be stored in that variable. That is you are telling the. That's why it doesn't take space in a memory. So how to declare a variable? Okay. This is your own data type. So you write struct student s1, right? So here s1 is name of variable. S1 is name of variable. Can you see the similarity between any variable like index and this? X is also name of variable. X is a name of variable whose data type is int. You can store integer constant. S1 is also name of variable, okay, but whose data type is struct student. So you can store information of student in S1. So S1 is going to take memory because it is variable. S1 is going to take variable. Now, what is the benefit of this? Benefit of this is that when you declare S1, there will be one structure, okay, contiguous memory, right? Like this whole variable is a S1, right? This whole variable is S1. Earlier, when structure was not there, I mean, you declare these many variables, same memory will be given, same amount of memory will be given, right? But problem is that no guarantee that this will be placed like this, right? The roll number will be here, right? Name will be here, age will be here, address will be here, birth date will be here, birth month will be here, right? And birth year will be here. So there is no internet, there is no connection between them. You can store the data, you can access the data, but there is no relation in between them. All right. Likewise, I have given some examples in the uh, your e-learning course. Okay. Whenever they want to, I just this I cannot explain in that e-learning, but I will give example. When you read any sports news, I have given that example. Not I have not elaborated that. Okay. When you read any sports news, right, in the newspaper, hmm, or current situation, a pandemic, COVID-19, right? See, there is a news like, okay, in Delhi, there are so many disease, so many affected, so many what uh, discharge, right? In Maharashtra, these are the figures. In Uttar Pradesh, these are the figures. Okay? So if they give news like this, okay, probably you may not read that because it is no, it is, I mean, it is disturbed. Disturbed means it is staggered. Okay, there is no like they give you like in Delhi these many are there, in Maharashtra these many are deaths are there, in Pashchim Bengal these many deaths are there. Somewhere they will again mention in Delhi these many are discharged. Again somewhere they will be in Uttar Pradesh these many are discharged. Again they will come to the in Delhi these many are newly affected. So same data is there. Data is same. But what if they give you in tabular format? Name of the state, right? They give in this format. New patients. Uh, for time now. Okay. Okay, this must be here, right? And discharge something, right? So here, suppose Maharashtra, right? Here, West Bengal, something like that. Okay, and they will write here data, something like that. Something. This is a very old data, right? Something. Some data is there. Mamata Banerjee will become happy if she reads this data, right? Whatever. Okay, we won't waste time here. Some data is there, suppose, right? So if if they give in tabular format, it is very easy to do everything. You can read that, you can access that, you can no, you can do everything there. Now here, if you apply the analogy, if you apply the analogy, initially they made the structure, right? Who those who want to give information. Okay, they made a structure. What kind of structure they designed? They might have given sorry, struct something, huh? Just imagine COVID-19 data, right? They define their own data type now. Okay, like this. They give char state, right? Suppose 100. They give int, suppose x. Suppose same name give new patients, right? Int deceased, int discharged. That's it. This is basically a structure they design. Once they define the structure, right? Same structure will be followed while storing the data in that format. So this is basically a structure. When this is there at the top, okay, you can store the data easily. So here, initially, initially, when you declare a structure, this was not taking any memory, right? When you write statement like this, struct COVID-19 data, right? S1, right? So which is S1? This is S1. And you store the data. You declare S2, S3, S4, right? So will be this will be S3. This will be S4. So, do you get what I mean? Now you are creating your own data type and you are creating variables now. Okay. So this is S1. You will store data. S2, store data. S3. So in a tabular format, you can see this. And this we call it is a structure. So this we call it the structure, and this we call it is the structure variables. So there is a connection. Okay. 234 are new patients of Maharashtra. Okay. So one single picture, there is the state Maharashtra, which has got 334 new patients. There are 12 diseased till date, and this 200 discharged. That's it. So there is a connection. It is not that you wouldn't have been able to store this data in different variables. What you would have done? Okay, you have declared as char state one. Okay, of suppose 50. Right? You would have declared variable as int, suppose now I will give small names, int y and int z, right? So this is going to take same memory. This is going to take same memory for one data of one state. Okay, memory will be same, but handling is difficult. So here you can write the same. No, you can write state something like that. Hmm? X is equal to Y is equal to Z is equal to. So data is, but there is no connection between this and this. These are completely independent. Whereas, as far as this is concerned, this is bind together. Right? That is the structure. So I hope this much efficiency, this much explanation is, I think, uh, you haven't probably might not have understood only, but you will remember it forever throughout your life, right? So this is S1. Now how I can store the data? I'll store the data. There is an operator called dot operator. So now you cannot write like this. What is this? That's it, right? So now I cannot write roll number is equal to something. No, it is not possible, because it is not a, it is a, I mean, you can do this, but this is going to be a different variable. Right? This is going to be a different variable. So I want to store roll number of S1, roll number of name of S1, name, age of S1, address of S1, birth date, birth month, birth year, like that. So I will write S1 dot. I'm not getting help. So, warning. Okay. We haven't used that variable, right? So S1 dot, right? What? Roll number, right? Dot operator. Roll number of S1. So that's why S1 dot roll number is equal to suppose 101, right? Save and open. Not some problem is there. I'll open this again. Right? I'll write S1 dot name. But friends, in the last chapter, I forgot to, rather, I didn't forget, but that is very important. As far as string is concerned, you cannot write string like this. I don't know whether you wrote the program of a string copy, Ashutosh. I had given you that library function as well as right. So you cannot write s1 dot name is equal to something like you cannot write like this. This is invalid. Okay? You need to call string copy function here, right? So you will write str hash include string dot h, and you wrote. There is a reason for that. I will explain it afterward. You should not assign string. Okay. So str cpy, right? And it takes two arguments: target string and source string. So you'll write name. No, what is target string? We want to store name in this not of s1, right? So s1 dot name, comma, we'll write right. We will write s1 dot age is equal to suppose 17. S1 dot address you cannot write like that. So again your str cpy, here you want to store in the address of right. A string has to be copied. Should not be, you should not assign that. B date is equal to, so I'll write here 26. Right? E. I'm not able to understand why it is not giving help. Is 3. B is equal to 2000. That's all. So this is the structure definition. This is the structure variable declaration. And this we have stored the data. Now this data, right, will be stored here. Like what that what 101. Ashutosh, Delhi, 26, 3. Right? This is the X1. See, this is not an array. You may feel this is an array. This is not an array. Array is a collection of elements having same data type and same nature. So this is not an array because this is integer. First of all, okay. This is string. This is again integer. This is string, integer, integer, integer. So this is a structure variable S1. Now there is a relation. There is a name Ashutosh whose roll number is 101. Okay. What is this? I don't know. Age, I think, no? Age. Yeah. So age is suppose 20. Right? So 101. I put that age 20. Right? Who stays in Delhi? Whose birth date is 26, birth month is 3, and birth year is 2000. So one shot, everything is there. Imagine what this data is stored like this. No? 101 Delhi Ashutosh 26 23 and 2000. relation, no relation at all. Data is same. Data is stored in the memory. It is everything is going to take. This is going to take certain type of amount of memory, and same amount of memory will be taken by this. If you want to check that, you can use the. I have talked about this on the size of operator. You want to check? You can check here. Printf. So memory reserved is percent %, right? And then I write we have to take that size of int, size of char, size of float, size of double. That we have done everything. So use the same size of. You can write S1, or you can even write size of. We wrote size of student int, right? So in the same fashion, int is the built-in data type. Student is our own data type, right? Right? Not student, step student. Because size of student only will give you, may give you an error. Additional. Right? So if I compile this program, what is this? Yeah, S1. But that it gives you immediately error because that is a structure variable or structure member. So it didn't recognize that. What is this? Semicolon. So if I compile and run this program, see memory result is how much? 172 bytes. Okay. That is I mean cumulative memory of roll number, name, age, address, birth date, birth month, and birth year. Right? That is cumulative. So individual memory, okay, this is going to be 172 again. And this is going to be 172. But here you have an advantage. Everything is connected. That's is the need of a structure. That is a need of the structure. So you can print all these things now. Print roll number, int, right? And you have to follow that S1 dot roll number. It's surprised it is not giving any help. Got some, it doesn't happen. Print name of a student. Percent S, right? Right, S1 dot name. You have to attach that. Print age, send D, slash n, S1 dot age. Printer address equal to percent S slash n S1 dot address. You can even write put S1 dot address. You can do that because it is a string, right? S1 dot enter percent D percent D percent D slash n S1 dot b date comma S1 dot b month S1 dot b year. That's it. Right? So the whole data is stored inside a single variable S1. You got that? Okay, so that slash n is I forgot. So see here, the whole data of one structure variable, that is S1, and S1 is of type struct student. So struct student is your own data type now, rather our own data type. So memory reserved is 172, that is okay. Roll number 101, name is Ashutosh, age is 20, he lives in Delhi, he is birth date. Got that? Right? So structure is just no, it is a magic given by the gift given by the great Dennis Ritchie. So you can no now all other rules will apply here. Similarly, you can declare three variables S2. Store that. Now this is assignment. Like basic data type, primary data type, we can initialize. Structure variables also can be initialized. I will write S2 is equal to, because we have declared one more variable. How to initialize them? In a pair of curly braces. So I will write same sequence you have to write here, right? So roll number, suppose 102, right? Same sequence you have to follow. Name, suppose Tanmay, right? What is next? Age. So I will write how? No, age is third, right? So I have to write here age 24. Then this is address. Then C, right? So B. This is string, right? No, 5. Then 1996. That's it. You can print that data as well. So I try to cover everything, assignment as well as initialization. Okay, just change here. It's two, it's two. Now I think it will work. Rather, it should work. Yeah. So got that. Now there are two structure variables of struct student data type. This is one, right? This is all information of Ashutosh, and this is all information of Tanmay. Right? So basically, this is the structure, my friends. I hope you have understood everything. I'm quite sure because structure is not taught the way it should be taught. That is a big problem. That's why student doesn't understand structure. See, this is a building block. They do not understand structure, so they do not understand data structure. They do not understand class in C++. Since they do not understand class in C++, they do not understand object in C++. So they don't understand what is class and object in Java, and ultimately they do not understand Python or all programming language. So the root lies in understanding the structure. Because class, objects, object-oriented programming, all has been derived from this structure concept. I hope you have understood what I mean in last 1 hour. Because I taught you so many intricacies of structure, importance of that structure, need of the structure, dot operator, right? It is also called as a Here it is a dot operator and uh, structure definition, structure members, memory taken by the structure, declaration of a structure variable, and assignment, and structure variable initialization. This is initialization. That's why it gave an error. Okay, that's why it gave an error. Right. So everything I tried to cover. Okay. Now, if I declare, suppose struct student, right? I can write statement like this: S3 is equal to S2. This is valid. So whole data inside one structure can be copied to another structure. This is copying one structure that is to S3. Now, Ashutosh, you asked me what is that arrow operator, this, that. Okay. I'll try to cover here only. Okay. In one single program. Suppose I want to send a structure to the function. See, structure is usually defined data type. And built-in data type you are sending X, you are sending Y, try to send an array, you try to send the string as well. So what is the problem in sending structure to the function? Yet is it possible? So I will call the function one display, right? We'll print the data, that's it. We won't do anything more. Okay. I will write here void display. What it will take? Struct student. Right? That's it. Because it is going to take structure variable, right? So it has to be struct student. Right? S3. Right? Void display, and I'll write you are sending X having int data type. So at the other end, as a formal variable, you declare the int Y, some kind of thing. Same philosophy. Once you understand the basics, you can do anything. So you are sending structure variables. It has to be collected in a same type of data type. So what is the data type? Struct student, right? And give here another name. Suppose what can you give? What any variable name? Suppose D. Okay, D is the name of the student. Right? So you can write everything here. Made a mistake. You copy. Mistake is bound to happen. Programmers are always busy copying something. What is this? Okay. This is one of the fundamental concept. Okay. Can anybody tell me what might be this meaning of this? Meaning of this is that this is not taught many times. See, basically, you have declared a structure, right? I think that might be the problem. Huh? You have declared a structure, you have informed the compiler, you are intimating the compiler that this is my own data type whose name is student, and these are the members of the structure. But as we know, this structure has been declared inside main function. So that's why it is recognized, it is visible inside main function. And since this is the other function, it is not able to. This is not recognized because scope of this is this. Like you are an Indian, right? You don't have passport. If you go to other country, will they recognize? No, because you don't have document. So similarly, this has to be written below this. So structure is usually defined or declared inside main function so that it is accessible to all functions in that file. All functions in that file. So probably I think error should go. Yes? Okay. So now since this structure has been declared outside main function, now this definition is available for main as well as whichever functions you write in that file. So got that? This is copied structure, right? This is S2, this is S3. So you can send a structure to the function, right? Now, there is a overhead. Here is the overhead. 172 bytes you are sending. Earlier you were sending just XYZ, no? You are sending X and collecting in a Y. Huh? Before pointer. You are sending X and collecting Y. Right? So at the most 2 bytes, I mean, Y used to be as a formal parameter. The actual I mean, contents of actual arguments were are copied to the formal argument in the function. Right. On that, we found the way. We send the address of array, address of string, right? I think you can remember you were sending base address of an array, so that when you send the base address, whole array was not getting copied into the function. Similarly, same thing we can do here. What we can do here, because structure is a huge overhead. Okay, just see 172 bytes of one structure variable. So all that 172 bytes will be copied into another 172 bytes, right? So what is the remedy over this? Remedy over this is send the address. That's it. You send the address of the structure variable, right? Make necessary changes here, right? Not stuck student stuck, right? So make this pointer variable, right? And when you write pointer, use the arrow operator. Now it is coming help, right? So now you are using pointer. So write ptr arrow, right? Name, right? I hope you are getting. If I Um, if you feel I am going fast, don't worry. I am going to teach you again. PTR arrow. But once you finish today's lecture, as soon as go to the structure chapter in my animated course and finish that at once, 1 hour at the most, I think. Okay, everything will be fine. Everything. I think what is the use of, and I have explained that using animation, so don't worry. Benefit of this now pointer is that in the earlier case you were sending 172 bytes. Now here you are just sending an address. You are not copying anything, and remotely you are accessing everything. That is the that is the greatest benefit of sending an array using address. Hmm? That's it. Right? So you know, in one single program, if we can see, I have covered everything, everything up to the deepest level. Need of a structure I have defined, declaration of structure I have shown, structure variable declaration I have, only one concept is remaining. Structure variable declaration I have seen, how to access structure elements using dot operator I have seen, array of structure is just remaining. Feature of structure I have told. Okay. If something is remaining, I'm going to cover. Don't worry. This is not the only first lecture. I'm going to take one more session on structures and structure pointer. Right? Let me check whether it is either user defined data type. This I have covered everything. Size of a structure I have shown you. Appropriate definition I have shown you. Something is remaining, but trivial point is not very important. I wanted to just the cover crux of the structure, right? Other trivial things are there going to cover in the next session. Okay, various ways. I have not yet showed this. I will show you this, right? Type def I have not yet shown you. Okay, intentionally I didn't teach you type def today, right? So that you will understand the importance of type def tomorrow. Then dot operator I have showed you. Structure operator is means arrow operator. Okay, structure operator means arrow operator. Copying one variable to another variable. I have shown this. There is a member-wise copy and direct copying. I have shown you direct copying, not member-wise copy. Member-wise copy is like no. Instead of E3 is equal to E2, you will write E3 dot birth date is equal to E2 dot birth date. That is a member-wise copy, right? Nesting of structure is remaining. I am going to come that. Passing structure to function I have shown you. Okay. So almost 70% I have covered by taking only one example. Right? Arrow operator I have shown. Passing structure to function I have shown. Right. So we will stop here.